This question looks a lot scarier than it is. This is actually really easy if we use our strategies and if we've memorized the correct formula. So for the SAT, the most common formulas that we use are y equals mx plus b, some of the equations of a quadratic, but circle formula kind of fits in there as well. It's not something that is given to us. It doesn't come up often, but a lot of times we just kind of need to memorize it. So let's throw that in here. Memorize, definitely part of this. And if we do, that's going to get rid of two answers immediately. So the main way that the formula works is it's x minus h squared plus y minus k squared equals the radius squared. And so there are the two pieces. R is equal to the radius, and hk is the center. So both of those things are kind of easy to memorize in a way, but they're also easy to mess up because both have a little bit of a complication. So the radius, when we see it in the formula with an actual number there, is always going to be squared. So the actual radius will be the square root of whatever number is on that side. The other problem is that the center ends up getting kind of reversed when we put it in the formula. So if I were to take this point and put that into this formula, I'd have x minus 0 squared, so I'll put it, plus y minus 4 squared equals, we don't know the radius yet. And so what ends up happening is even though the center point is positive 4, it looks like negative 4 in the equation. So you got to remember that. That's going to come up. It behaves similarly to the way that quadratic equations work when we factor. So we do have some precedent that can help us kind of memorize it, I hope. But that gets rid of some answers for us. That gets rid of B and D. And now this is where people have some trouble. We have a scary looking number. It's not giving us the radius, right? It's giving us the end point of the radius. But it's not in like one of the normal directions, right? If we were going directly from our center point up or down or left or right, we would be able to see what the radius is very easily because it's only moving in one direction. This is more of a diagonal, so it kind of throws things off. What I recommend is to use one of my favorite strategies, plug points into equations. And this is especially important for circles because it also provides one of the cases where this strategy won't work. So the center, we can't plug the center point in for x and y in the equation. We won't get a valid result. And the reason is that this equation of a circle describes the outer edge, the circumference of the circle. So it's telling us like the outside, but the equation does not represent any of the middle points, including the center. So it's kind of there, it's built into the equation. But the x's and y's specifically are the x's and y's of the points outside the circle, along the edge, okay? But that's what we have. We have the radius as an endpoint. So somewhere along this outer edge is this point 4/3, 5. So what we can do is plug that in for x and y and see what we get. And because A and C have the same variable combinations here, we only have to do this once. So what I would do is I'd say, okay, 4/3 is my x, so let's square that, plus y is 5, so 5 minus 4 squared. And I don't know what it equals. It's either going to equal 5/3 or 25/9. Let's see. 4/3 squared, we have a calculator, but we should also know how to do that. It squares both the top and the bottom, so that's 16/9. And 5 minus 4 is 1, and 1 squared is just 1. So okay, that's not so bad. Now in order to add fractions, we need to have common denominators, but with the number 1, that's really easy because that's just 9/9. And so 9 and 16 is 25/9. And so there. That is proof that choice A is the answer. That's what we got. You may have already noticed, but the radius then is 5/3. 5/3, because if we think about it, if this is r squared, then r is going to be the square root of that. The square root of 25 is 5. The square root of 9 is 3. So if we plugged that in for that r squared there, then we would have 5 thirds squared, which is the 25 ninths. So we don't need to know that for this, but there it is. That's how it works out. And I do think that for the most part, you're going to want to use the plug points into equations strategy whenever they talk about a point that's on a circle, okay? That is definitely better than trying to like figure out the radius some more complicated way. I think it's safer. You're going to have versions of the equation, so stick to that. And it's why I love this strategy, because it works on lines, it works on quadratics, it works on random kind of things. And right now, plug points into equations also saved us on circles.